Section 3.2 is another easy section. It's going to be tedious as much as anything. It might get to be a little long where I have to split it into two parts. I kind of think that's going to happen. I'll just start and try to not make that happen, but I guess it will. So in the last section we did frequency distributions, which are these lovely two-column tables. In this section we're going to make histograms, and a histogram is just a bar graph or a bar chart. And frequency polygons, which is just, in some sense, I guess I'll call it a line graph. It's maybe not the best definition, but it's adequate. And let me just jump into it. So I'm going to create a histogram for the frequency distribution below. Usually, when I make a frequency histogram, I make essentially a first quadrant of a XY axis, and the left column I label the bottom or the x-axis in some sense. And the y-axis I label the second column. It just kind of feels natural to do this. X's and Y's and so along the x-axis I'm going to put the numbers 0 through 9. I could put the 0 right at the corner, but I'm going to write it a little off to the side of the kind of origin. And best I can, I'm going to squeeze the numbers from 0 to 9. Try to reasonably equally space them. And then on the y-axis, I need to get all the way up to 18. If I want to, I can mark by 1 on the y-axis, or the number of family axis, or I can go by 2. I'm going to go by 1, just because it's the first problem. Once I do more of these, I'm going to start really incrementing in big jumps on this vertical axis. I'm already kind of regretting not going by 2, because I'm going to get up to the top of my paper before I'm done here, I guess. And now above each number on the x-axis, I'm going to make a spot for the number on the y-axis. So above 0, I need an 8, and all I'm going to do is make a bar that captures this 0, and that's going to be the first bar in my histogram. Above 1, I need to go up to 11. Guess that's about 11. I'm going to make a bar there. My bars are connecting this time. Sometimes they won't connect. I try to make the number kind of in the middle of the bar. It's hardly that big of a deal if it isn't. 18 I'm going to go up to for the next bar. It's nice if all my bars are kind of uniformly wide, but I hardly care if they're not. I'm not going to take points off for, bad art in some sense. But I'm just estimating the height of each one of these bars and drawing it. And this is going to be called a histogram. And this is my histogram. For this frequency distribution. Simply a bar chart. When I go to make my histograms, sometimes when I use Excel to make my histograms, it doesn't connect the bars along the bottom. Hardly a big deal to me whether they're connected or not. You'll be able to see here, when I did this on Excel, this is what Excel did for me. It's basically the same thing. I have the numbers 0 through 9 along the number of children horizontal axis. The number of families, increment it by 2 because it's a little bit easier to do it by 2. Whether the bars touch or don't touch makes no difference. You could actually have bars going horizontally, but for our class, all the bars are going to go vertically. So frequency histogram from a set of data is real easy to do. A frequency polygon is equally easy to do. For this same set of data, if I want to make a frequency polygon, all I'm going to do is on the same sort of setup, X-axis or horizontal axis labeled number of children, Y-axis or vertical axis labeled number of families. I'm going to put the numbers that I need from the X column along the X-axis, put the numbers on I need for the Y column along the Y-axis. For whatever reason, I went to 10 and 19. I didn't really need to go that high. For each value, I'm going to make a point. Here, my 0 starts right at the corner. That's fine. I could have not labeled this, and I could have labeled that 0 and went out to 9. It really doesn't matter. There aren't hard and fast rules. As long as along the X-axis, somewhere you have the numbers at least 0 through 9. And on the Y-axis, a space for 0 through 18. You could go, you could have did 2, 4, 6, 8 all the way up to 18. And now above each number on the X-axis, I'm going to find the correct Y. So above 0, I found 8. Above 1, I found 11. Above 2, I found 18. Above 3, I found 11, and so forth. And to make this a frequency polygon, which is a line graph, after you get all the points plotted, then you just connect each individual point with a line. And when you do that, you now have a frequency polygon. So a frequency polygon is hardly different than the bar chart, but instead of, I don't even know what I did. Well, instead of, when I made the dot making a bar, instead of doing that, I connect the points that I make with lines. And I could, on the same graph, show both a frequency histogram and a frequency polygon. A lot of times if you're doing your homework, because it's such a nuisance to make the X and the Y axis, you can make a combined frequency histogram. You get histogram and frequency polygon. This would be a combination graph that shows both a frequency polygon, which is a line graph, and a histogram right on the same graph. More often than not, that's what I'm going to do when I'm asked to create these drawings. So, homework already. Problem 1, create a frequency histogram and a frequency polygon. I'm going to put them on the same graph because I'm lazy. I'm going to do your problem 1 with you. So I need to make up two, the first quadrant in some sense of a graph. The units along the horizontal or X-axis, I'm going to call number of children because that's how it's labeled. And along the Y-axis, I'm going to label this number of families. I need to get the numbers 0 through 9 along my X-axis. And I usually, when I'm doing it by hand, don't start the 0 right in the corner because it makes it easier to get my bar in. Otherwise, it's kind of funny because I like my bar to be kind of centered over that number. And if the 0 starts right at the edge, well, then it's hard to make that happen. 6, 7. Being able to count to 9 doesn't hurt. I need to get up to 18 again. I don't want to increment by 1. I can increment by 3s if I'm comfortable doing that. I can increment by 2s, just as long as I can get up to 18 on this Y-axis and estimate the numbers that need to be estimated. That's going to be sufficient. When I do these by hand, more often than not, my bars connect. Notice here I called it a frequency histogram. I'd been calling it just histogram. Those are interchangeable. So I'm going to make my histogram in blue. Above 0, I need to mark 8. I'm going to make a dot there and make a bar. Above 1, I need to go to 11. I need to estimate 11. It would have been nice if this bar didn't go over so far, but it is what it is. There's my bar above 1. Above 2, I need to get to 18. Try to make this one a little bit narrower so I'm not, there, it's more centered. So I'm going to get these points really labeled out because I'm going to use those to make my polygon. Above 3, I need to go to 11. Above 4, I need to go just to 6. Above 5, I need to go to 4. Above 6, I need to go to 2. Above 7, I need to go to 1. I'm estimating the 1s and the 11s and the odd numbers. 8, I need to go to 2. And 9, I need to go to 1 again. So that's my frequency histogram done in blue. I'm asked to draw both a frequency histogram and a frequency polygon. I'm going to do them on the same graph. You certainly don't need to use multicolors, but since I have the colors available, I'm going to do the frequency polygon in red, and each of the heights, the height of 8, 11, 18, 11, and 6, now I'm just going to connect those dots that I used to kind of mark the height of the bars from the histogram. I'm going to connect them with little line segments. I don't need rulers to do that, but I could have rulers to do that. And that's all there is. That's everything for problem 1. I've created a frequency histogram, which is a bar graph. My bars are connecting, which is hardly that big of a deal. I've got wide bars and skinny bars. I don't really care that much. And a frequency polygon, which is a line graph. When you go to do problem 3, on the y-axis, it's going to be a little bit different. I'll do problem 4, which is essentially asking me to do the same thing, make a histogram and a polygon. And the only thing different is I'm going to put this whole class along my y-axis. So if I was doing problem 4 and I was asked to make a frequency histogram and a frequency polygon, and I tried to sneak them on the same graph, my x-axis for me I'm going to call class. My y-axis I'm going to call frequency. On my x-axis now, I'm just going to make little marks. I'm going to call this mark 40 to 49, this mark 50 to 59, and then 60 to 69, 70 to 79, 80 to 89, and 90 to 99. And then on the y-axis, I need to get up to 7. I can do that by 1, I think, without getting too high. When I increment by something other than 1, it's just because I don't feel like writing that many numbers as much as anything. So above 40 to 49, I'm going to make a dot at the 7. And let me this time not connect my bars if I can try to do that. It doesn't matter whether they're connected or not. Above the 50 to 59, I'm going to put a bar that's 5 high. Above the 60 to 69, something that's 3 high. 70 to 79, 2 high. 80 to 89, 7 high. And 90 to 99, 1 high. So my frequency histogram, or just my histogram, is in blue. I almost never make histograms and polygons on separate graphs because it just takes so long. So I'm just going to pull out my different color and make my frequency polygon on the histogram by taking each of the places I used to mark the height and connecting them with straight lines the best I can. And so that's everything for problem 4. I have my frequency histogram, I have my frequency polygon, all on the same graph. I have my x and my y-axis labeled with the data from the frequency distribution, and I didn't connect my bars this time, but it doesn't matter. I will never take points off if you do or don't. There isn't like an industry standard on whether the bars should be connected or not. So there's your problem 3. And you can pause the video and give it a go. Next activity is making stem and leaf displays, which I've never asked on a test, but I'll explain them a bit here. So a stem and leaf display is another way, another tool to organize groups of data while allowing us to actually see the actual values, which is kind of nice, because in this table, I don't know, I guess I can see the actual values, but in a stem and leaf is another way to organize data, and you can see all the values that make up the table. Which is kind of nice. And then to make a stem and leaf display from given data, you need to break the data up into 2 groups, a left group and a right group. The left group is called the stem, and the remaining group is called the leaf. There are no rules for the number of digits to be included in the stem. Basically, the stem and leaf display breaks the numbers up into two parts, and let me just explain how that can go. So the number 53, if I need to break it up into a stem and a leaf, probably there's only two numbers and I need two components, so I can call 5 the stem and 3 the leaf. For the number 483, I could make two different ways. I could call 48 the stem and 3 the leaf, or 4 the stem and 83 the leaf. And I will tell you what I want as we go through the homework to make up a stem and leaf diagram. And the number 6, because there's no number in front of the 6, it's only a one-digit number, I have to think of 6 as 0, 6, and I'm going to make 0 the stem and 6 the leaf. So any 2 or 3-digit number or even 4-digit number, I'm going to break it up into pieces. Usually the first number and then the rest of the numbers is the way I break up stems and leaves. So if I was making a stem and leaf display for the number 483, I'd probably make 4 the stem and 83 the leaf. All right, so here's an example just to give us an idea of how to make a stem and leaf diagram. So the following data represents the ages of 20 guests at 4 p.m. when happy hour starts at the Yard House. The stem and leaf display has been started. Finish the stem and leaf display. So I took all the numbers and I wanted to make them into a stem and a leaf, and I separated the tens part. So in this left-hand column, I took the 2, the 3, the 4, the 5, the 6, and the 7 that were in the tens position. I call that my stem, and then I'm going to make my leaf or leaves, and next to the 2, I wrote a 7 and an 8 and a 9, and this represents 27, 28, and 29. So I can see the three numbers that were in the chart without showing the whole chart. I guess that's maybe why this is nice. The next place, next to the 3, I put a 1, a 2, and a 9 for the 31, 32, and 39. I'm just asked to finish this. I can't imagine this is rocket science. Next to the 4, I'm going to put a 3, a 4, a 4, a 5, and a 7. So I'm going to go 3, 4, 4, 5, and 7. Next to the 5, I'm going to put 0, 6, 8, and 9. Next to the 6, for the 60, I'm going to put 0, 2, and 8. And next to the 7, for 70, I'm going to put 1 and 2. So this is a completed stem and leaf display for these 20 people that were at the Yard House for some happy hour at 4 o'clock. I didn't even take the time to label what the stems or the leaf means. I don't do a lot with these, so we're not going to get really crazy with those. All right, so homework number 5, I'll do it with you. Let's make a stem and leaf display. The table below indicates the ages of each student in a recent Math 142 class. Do a stem and leaf display. Well, I'm kind of stuck making the stems the first number and making the leaves or leaf the second number because there's only 2 digits, so I'm not going to get confused. So my stems are going to be 1s, 2s, 3s, and 4s. For the teenagers, 20-year-olds, 30-year-olds, and 40-year-olds. Next to the 1, I'm going to put an 8, an 8, an 8, a 9, and a 9. Next to the 20, or the 2, I'm going to put a 0, a 0, a 1, a 5, and an 8. Next to the 3, I'm going to put a 1, a 5, and a 6, and next to the 4, I'm going to put a 4 and a 9. That's an adequate stem and leaf display for the data that's given in this problem. That's all we're going to do with it. I'm not going to test on stem and leaf displays. They ask me to expose you to them, so you're being exposed to them. I'll let you do problem 7, and I won't even do another example. I'll start it for you just in case. So these are the starting salaries in thousands of dollars of recent computer science majors. So $42,000, $45,000, up to $73,000. Construct a stem and leaf display. I'm going to make my stem, my leaves. Since these are 2-digit numbers, I need to separate each of the 2 digits. One has a stem, one has a leaf. My stems are going to be 4, 5, 6, and 7, and then 2, 5, 8, and 9 might be the first leaf that I'm going to do. And I'll let you finish that up. That can't take but 2 minutes to do. The next thing we're going to get into is circle graphs. I often call circle graphs pie charts. It's just kind of what I grew up calling them. And in order to make a circle graph, it's going to be helpful if we're asked to create a circle graph to be able to represent percentages of a circle pictorially. And so here's a big circle, and if I wanted to make a region of this pie chart that represented 50% of the graph, I could just take that circle and cut it into a perfect half. This region right here, whether it's tilted like this or not, represents 50% of the area of that pie graph. If I cut the 50% in half, and that's what's up here, this now is a 25% region. And if I cut the 25% region into halves, I get regions that are 12.5%. So cutting a circle in half once, you get an area that's 50% of the circle. Cutting the half in half, you get 25%, and cutting the 25% in half, you get 12.5% regions. We're going to be asked to draw pictures of circle graphs or pie charts, and it's going to help to have these relative sizes in the back of our mind. That 50% is a half of a circle, 25% is a quarter of the circle, and 12.5% is half of a quarter in some sense. I don't know how useful this is going to be, but I made a picture of a 90% and a 10%, and that I have a hard time fudging. 10% is just a little bit less than 12.5%, so on this graph, maybe that might be like 10%. So let me show you an example of what we're actually going to do. And on the tests, if I ask you to make a circle graph, I usually make the numbers really tolerable. So I told, as I started writing this up, I said for the most part, I just eyeball it when I create circle graphs. I'm not that particular about them being super, super precise. If I need them to be precise, I'm just going to use Excel to make them. So I generally know about how large I need to make each region. I just try to get close. I never really measure. So in this example, 600 people exiting the AMC movie theater at Arrowhead Mall were asked what type of movie they've just watched. And 150 of the 600 said they saw action, 300 of the 600 saw a comedy, 75 saw a drama, 75 saw a sci-fi movie. Now I want to make this into a circle graph. And how do I do that? I'm going to take each number and make it into a percent because it makes it easier for me to get my circle graph. So 150 of the 600 people that were in the theater, coming out of the theater, saw an action movie. I need to make that to a percent. To make that to a percent, I divide the 150 divided by 600. That's going to be 0.25 as a decimal, and I know that's 25%. So when I go to make a picture for a pie chart for this, 25% of the graph is going to represent the action movie watchers. To make up for the comedy, I'm going to take 300 divided by 600 to figure out what that is as a decimal. I can do that without my calculator. That's 0.50, which is going to be 50%. And for the drama and sci-fi, to figure out what size their pies are going to be in the pie graph or circle graph, I'm going to take 75 divided by 600, 75 divided by 600. I get 0.125. And that's 12.5% of the shape. So I made these numbers the same as what we just looked at. Makes it easier to do. So let me make a circle graph. To make a circle graph, technically you need to be able to draw a circle. I like to go from biggest to smallest as I make these circle graphs. It makes it easier for me. And the easy part to draw here is comedy. So I'm going to make half of the circle. So I just drew a line and cut the circle in half. And on one of the halves, I'm going to call it comedy. And I'm going to put the percent that was related to comedy right in the graph. The next percent I'm going to draw is for the action. And for the action, I just need to cut this bottom region, which is 50% of the graph, into two pieces. Both of these are 25%. It doesn't matter which one I call action. I'm just going to call the left one action. And put that this is 25% of the graph. The last two are 12.5%, and again, 12.5%. This region right here is 25%. Half of 25 is 12.5, so I'm going to make those 12.5%. And if you can't fit in the pie, you could just make an arrow and say this region represents drama, which is 12.5% of the attendees. This region represents, I'll just say sci-fi, which is 12.5% of the people that were surveyed. This is how we're going to make circle graphs or pie charts, and this isn't the only way to do them. You don't always see the names of the categories inside the pie graph, nor do you always see the percents. For me, it makes it easier when I see that, and you'll see that when I did this on Excel to get my answer, Excel did this. It gave me the pie chart. I don't even have a chart title here. I guess I could have named it movie attendance. I didn't even give it a name. But Excel did this, and I didn't know at the time when I made this how to make Excel do put the names in the circles. And that's kind of bad because now that this is black and white, you can't tell that comedy is this region. I can't tell that action is this region. And quite honestly, I'm not sure which of these is which. I think this is drama and this is sci-fi. So Excel, when it did it, it color-coded these, but we don't have a color printer here, so when I printed it out, it didn't print out so nicely. But for our purposes, when we go to make a pie chart, we're simply going to, for each number that's given, find a percent by comparing it to the total, and then make circles that fit these sizes. So we're asked to do 3 pie charts. Let me walk through number 9 with you. You're more than welcome to make up your own pie chart without watching me. So I'm going to make a circle graph or a pie chart for the number of people that have certain phones. So 50 people have so 50 people that were asked what kind of phone they have an iPhone, 25 with a Galaxy, 10 with a flip phone. I saw friends with flip phones, 10 with some other phone, maybe the new Google Pixel phone, which all of a sudden won't be new 4 years from now, and then 5 with no cell phone. So let me total this up real quickly. 50, 75, 85, 95, 100. There were 100 people asked what kind of phone they have. That's going to make it real easy to make these numbers into percents. The first number, 50, to make it a percent, I go 50 divided by 100. I get 0.50. That's the same as 50%. Because the base is 100 here, or the total that we're dividing by, these numbers are all equal to the percents. 25 divided by 100 is 0.25, which is 25%. 10 is 10. And then 5%. This is going to be tricky to draw these bottom 3. So I'm just going to have to just wing it. And again, I'm not going to try to be that accurate. So there's my circle. First thing I'm going to put in is the iPhone. It doesn't matter where I put it, but I should be able to make a pretty decent approximation of 50% of the graph. There's my iPhone. That's an easy one to get in. Now the Galaxy, which I used to own an iPhone. I just got a Galaxy recently. I'm going to make 25%, which is just half of the half for my Galaxy. Now the rest of it, I need to break these into 3 parts, and the 5% is the smallest, the two 10% are the equal. I'm going to try to fudge a 5%, and this is just a guess right now. I'm going to make something that's kind of small here, and I'm not being that accurate. I'm going to say no cell phone is 5, and then the rest of the figure needs to be 2 equal halves, so I'm just going to divide this into 2 equal halves, At least that these two are bigger than that. They're technically supposed to be twice as big as that. I don't know if they're exactly twice as big as that, but I hardly care. I'm going to call one of them flip phone for 10%, and the other one, other, for 10%. That's a completely adequate pie graph, circle chart, circle graph, pie chart for this. And yours can be orientated differently. You could have the iPhone being the side, one side as opposed to the bottom. It doesn't make any difference to me when I ask you to make a circle graph where each of the wedges winds up, just as long as the wedges are about the right size. 50% and 25% are the easy wedges to put in. The other ones that are different than 50 or 25%, you can just kind of play around with it. I'll get you started with number 11, which is the last circle graph that you need to do. So we're apparently a bunch of people were asked what their height was, and 100 people said their heights between 5'5" and 5'6". 80 said between 5'7" and 6 feet, and 20 said over 6 feet 1. If I add up these numbers, there's 200 people that are represented here. I need to change each of those into a percent. So the 100 people that were in the first category, I'm going to divide 100 by 200. This is going to give me 0.50. The region I'm going to make for this height is 50%. The 80, I'm going to go 80 divided by 200. That's 0.40, which is going to be 40%. And the 20 divided by 200 is 0.10, which is 10%. When you go to draw your circle graph, somewheres you need to make a line for the top category, the 5 foot 5 inches through, it's 5 feet through 5 feet 6. It's dumb. This is 5 feet to 5 feet 6 inches, and that's going to be 50%. That's the easy part. And now, these aren't solid numbers. I need to make this the smaller of the pieces, so maybe I'll come down here and call this 10% for the over 6'1". And then the other one I would label 5'7" to 6 feet, 40%. I basically did it for you in a very awful drawing, but it's good enough. I'm never, ever, ever going to go, oh, that's not 10%, that's 13%. As long as 50% is half, and then the other amounts kind of fit in. 10% should be definitely a lot smaller than 40%, and this is my 40% for the 5'7" to 6 feet, and that just kind of feels good. And it doesn't matter where the 50% is. I did it off to the side here rather than on the bottom or on the top, just to be different. Last thing we need to be able to do is we need to be able to answer questions if we're given circle graphs or pie charts or bar graphs. So this circle graph, I'm sure I stole it from Google Images because I don't think I could make this. But a survey was given to 200 people. The results were summarized in the circle graph. 22% of the people said basketball is their favorite sport, 18% volleyball, 29% soccer, and so forth. Question A, how many people said their favorite sport is tennis? Well, 18% of the 200 people said their favorite sport was tennis. I need to figure out what 18% of 200 is. To figure out what 18% of 200 is, I need to do two things. 18% I need to change to a decimal. Of I need to change to times. To figure out how many people 18% of 200 is, I multiply 18%, which is 0.18, times 200, and when I did that, I got 36. Next question. How many more people favored soccer than basketball? Well, I need to know how many people favored soccer and how many people favored basketball before I can tell you how many people more favored soccer than basketball. So I'm going to figure out how many people favored soccer first by taking 29% as a decimal and multiplying it by the 200 people that were surveyed. If you do this on your calculator, I think you're going to get 58 of the 200 people said their favorite sport was soccer. And then if I want to find out how many people had their favorite sport as basketball, 22% had their favorite sport as basketball. That's 22% of 200 people. That comes out to 44 people, because 0.22, which is 22% as a decimal, times 200 is 44. If I want to answer the question, how many more favored soccer than basketball, I'll just subtract these. 58 minus 44. There are 58 people that had soccer as their favorite, 44 that had basketball. The difference, there's 14 more people, because 58 is 14 more than 44, that had soccer as their favorite sport compared to basketball. So now we get to do some homework. Let me walk through 13 with you. Hopefully we can push through this pretty nicely. So a survey was given to 500 students, and the results are summarized in the circle graph that's nicely charted. So favorite music styles at our school. 2% of students said they like classical, 8% did alternative, 12% rap, 11% hard rock, 60% pop rock, 3% country. This has to be an old graph because country is so big now that that's probably more like 30%. But nevertheless, I'm just going to live with the numbers in this chart that I completely didn't make up. So for part A, how many students' favorite type of music is country? Well, 3% of the 500 favorite type is country. So 3% of the 500 had their favorite type as country. 3% as a decimal is 0.03 of mathematically means times. And I'm just going to multiply 0.03 times 500 to answer this question. And I'm going to get 15. So of the 500 students that the survey was given to, 15 of them had their favorite type of music is country. Part B, what is the most popular type of music? Clearly pop rock for this particular school because it has the biggest region of the circle. And then how many students say it was their favorite? 64% of the 500 say their favorite style is pop. That's the same as 0.64 times 500. Guess that's what, 120, no, 256. 320, duh. So the question is, what is the most popular type? Pop rock. How many students? 320 students make this their favorite. But you get 15 to go. And let me just talk through 15 just in case it isn't clear. 300 people attended a concert. The circle graph below summarizes the ages of the people who attended the concert. 31% were between 30 and 39, 34% were between 13 and 29, 25% between 40 and 49, and 10% greater than 50. This is tricky. How many people at the concert were 30 or older? So maybe I'll walk through this with you. For this, I'm counting, for part A, I'm counting these people in the 30 to 39 break. Those 31% were 30 or over. These 25% and these 10%. All three of these categories fit the criteria that the people were 30 or older. I need to see how many people this represents. And first I'm going to find out how many percent it represents. 31% are 30 to 39. 25% are 40 to 49. 10% are 50 or older. And 50, that's 66%. So 66% of the people at this concert were 30 or over. So I need to find out what 66% of 300 is to get part A done. For part B, how many were under 50? Well, I'm not going to count those. They're 50 or over. I'm going to count those because they're in their 40s, these people in their 30s, and these people in their teens and 20s. I'm going to count those. When I go to do part B, I need to figure out how many percent of the people are in the age bracket we're looking for. That's going to come out to 90%. And then I'm going to need to figure out what 90% of 300 is. I'll let you do that, but I'll write the answers down. For part B, 90% of 300 is 270 people. There were 270 of the 300 people were in the under 50. And then for part A, just so you could have an answer to stare at, 198 of the people were 30 or older. Let me do a bar graph question. So this histogram, if I look at it, this is the salary of employees for some company and how many employees had the salary. So between 0 and 10,000, I think there were 50 people. It looks like that would be 50. Between 11 and 21,000, that would be 300 people. Between 22 and 32,000, I think that's 250 people. Between 33 and 43,000, 400 people. Between 44 and 54,000, I think that's 550 people. 55 and 65, 450 people. Between 66 and 76,000, I think that's again 250 people, but it might be a little bit higher, but it looks good. 77 and 87,000, 350 people. And over 88,000 looks bang on 100 people. So I can tell you, if you said how many people made between 55 and 65,000, it looks to me like 450 people. So question A, how many people made at least 44,000? I need to figure out which numbers I'm counting, and for at least 44,000, that means 44,000 or higher. For question A, I'm going to count all of those people in they made at least 44,000, and how many people are in that? Well, there's 550 in that category, 450 in the next category, 250, 350, and 100. I have no idea what that adds up to, so I'll just add it up. 550 plus 450 plus 250 plus 350 plus 100. There are 1,700 people for this company. The answer to part A, how many employees made at least 44,000? 1,700. And then how many made less than 33,000 per year? That's going to be these people. All of these people made up to 32,000, but that's clearly less than 33,000. To do this one, I'm going to add up the heights of the columns, which are 50, 300, and 250, the heights that are less than 33,000. The answer to this, I think, is just 600. When you go to do your problem 17, so this graph shows the ages of people attending a high school assembly. So for some high school assembly, the ages of the students that were there were between 8 and 17. 10 students were 8 years old, 20 were 9, 40 were 10, 60 were 11, 80 was 12, 50 were 13. At a school assembly, not a high school, so that makes more sense. 40, 40, 20, and 10. So how many people were at least 15? What I'm going to do when you go to do this problem, at least includes the number. When you do at least 15, you're going to count those students because they're 15 or older. That's at least 15. For part B, how many were under 12? You don't count the 12-year-olds. When you go to do part B, the students that you're counting are just those students. I'll write down answers real quickly. You can pause the video and get an answer if you want. For part A, I believe the answer is 70. In case if I didn't make a math error in my head. And for part B, I think the answer is 112. Let me flash up 19, which is the last problem you need to do. You can pause the video and do it, or you can watch me do it. So, problem 19, 300 men were measured and their results of their heights in inches were given. So, these are the heights. The shortest guy was 63 inches or 5'3". The tallest guy was 74 inches, which was 6'2". And this is a number of guys that had that height. So how many had heights between 68 and 70? Inclusive, so including the 68 and the 70. For part A, I'm going to include these guys, and I'll find out how many guys this represents. Here is 10 guys that were 5'8", and 12 guys that were 5'9", and I think 15 guys that were 5'10". I'm going to add up those numbers, the 10, the 12, and the 15, and get 37. For part B, pause the video and do it if you don't want to watch me spoil it for you. How many men at heights greater than 72? Greater than but not equal are only going to count those. Greater than doesn't count the equal. And how many are going to be represented here? There's 4 that were 6'1" or 73 inches, and 3 that were 6'2" or 74 inches. So the answer to that's going to be 7. I really thought this was going to take longer. I was going fast just to try to get it done in one video, and hopefully I didn't go too fast. I don't think this is particularly hard. Almost every student, when we come to the test over Chapter 3, does really well, and if they miss points, it's not on this stuff. So I apologize if I went a little bit fast. Always can come visit me if you need some extra help.